This is an experiment to measure the density of a tennis ball. For this experiment, we are going to use a string, a tennis ball, obviously, a calculator, a pen, and a ruler. The first step is to grab the ball and wrap the string around the ball so that we can measure the circumference. We are doing this so that we can get the circumference, which will then be used with a formula to calculate the radius of the ball. Then we use a pen to paint the point that we have gotten. The point between the end of the string and here. Then I take the same string and I use a ruler to measure the distance. You might have to stretch the string a little bit since it was all carved up because of the ball. And I've gotten 20 centimeters. After measuring the distance or the length of the string, you record your result. Circumference of the ball is equal to 20 centimeters. Now that we have the length of the circumference, we use the length of the circumference to calculate the radius using the following formula. V1 is equal to 2 times pi times r. That we make r the subject of the formula, which is going to be like r is equal to V1 divided by 2 times pi. We use your calculator to do all these calculations. We're going to do 20. V1 is the value of the circumference, and V1 is 20 centimeters divided by 2 times pi. The answer is 3.183 and all those numbers, but we can round them off to 3 significant figures. The answer is going to be 3.18 centimeters. Now that we have the value of the radius, we can use the same value to calculate the volume. Volume is equal to 4 over 3 times pi times r cubed. V is the volume and r is the radius. The value of gotten is 134.7007,362, but we can just round them to one decimal place. After calculating the volume of the ball, we just proceed on measuring the mass of the ball. Now that we've measured the mass of the ball, we'll record. Now that we have the volume and the mass of the ball, we use them to calculate the density. The formula for density is equals to mass over volume. The mass of the ball is 57.34 and the volume is 134 0.7 centimeters cube. The answer is going to be 0.42568671112, but we can round this to 3 significant figures. The answer is going to be 0.426 grams per centimeters cube. Now we have to calculate the uncertainty of the readings with the jump we have just done and the measurements we have just done. The uncertainty for centimeters ruler is 0.05 plus or minus 0.05 centimeters. To calculate the percentage uncertainty, we use the following formula. Percentage uncertainty is equal to absolute uncertainty divided by reading times 100. The absolute uncertainty is 0.05 divided by 20 centimeters, which is the value of the circumference we've gotten when we measured the circumference using the string. The answer is going to be 0.25%. The same uncertainty for the circumference is going to be the same uncertainty for radius. So the value of the radius will be 3.18 centimeters plus or minus 0.25%. We've calculated this so that we can use this uncertainty in volume. Remember the formula for volume is V is equals to 4 over 3 times pi times R cubed. The uncertainty in R, which is radius, is 0.25, but in the formula for calculating volume, we have R3. So we'll have to add the uncertainty 3 times, which is the same as 3 times the percentage uncertainty we have. Is the total uncertainty in volume. To have the total uncertainty of the density of the ball, we have to calculate the uncertainty in mass as well. Since the mass of the ball is 57.34, then the uncertainty of this will be plus or minus 0.005 grams. To calculate the percentage uncertainty, we use the same formula as before, which is percentage uncertainty is equal to absolute uncertainty divided by reading times 100. The absolute uncertainty is this one, which is 0.005 grams divided by 57.34 grams times 100. The percentage uncertainty is equal to 0.00872%. Remember, in the formula for density, we divide the mass by the volume, which means the uncertainties would be like 0.75% divided by 0.00872%. But when calculating this, we do not divide, we add the uncertainties. So the final uncertainty will be 0.75% plus 0.00872%. which is going to be 0.75872%. Therefore, the final answer for the experiment for the density of the ball will be 0.426 grams per centimeters cubed, plus or minus 0.75872%. This is the final answer for the experiment.